Okay, so the next concept is the idea of mass versus weight. Okay, these are two different things in physics land. In all the rest of your life, you've been using mass to mean the same thing as weight, but in physics they are different but related concepts. Okay, mass is in kilograms. I will never say I weigh so many kilograms, something weighs so many grams. At least I will try not to say that because that's not correct. Okay? It has a mass of so many kilograms. It has a mass of so many grams. Okay? You can weigh newtons and you can weigh pounds, but you cannot weigh kilograms and you cannot weigh grams. Okay? That is mass. Okay? It is a measure of stuff that you have. If you go into outer space, you still have that stuff. Okay? So it's related to moles in that way. You can still do chemistry in space. If I have 22.4 liters of hydrogen gas at standard temperature and pressure, or any gas, I have 1 mole of that gas. Yes. Okay? The English unit for mass is not a pound. The English unit for mass is something called a slug. Now let's think about slugs. A slug is a crazy thing, right? A kilogram is the amount of mass that you have. If you take a mass into outer space and you can't put it on a scale and measure the force, this is what you would do. You would apply a force of 1 Newton on it and it would accelerate at 1 meter per second squared. Yeah? A slug is the amount of mass you have. When you exert a force of 1 pound, it accelerates at 1 foot per second squared. Now let's think about this. There are 4.45 newtons to a pound. So a newton is about 1/4 of a pound. That's not very much force. A newton is less force. And a meter per second squared is 3.281 feet per second squared. So think about this. A slug, you're exerting more force on it and it's accelerating much slower. You're exerting more than 4 times the force. It's accelerating at less than 1/3 the rate. So is a slug a bigger mass or less mass than a kilogram? Let me say that again. You're exerting more force, okay? You're exerting more force on it, right? It's accelerating at much less of a rate. Yeah? So is it a bigger mass? Or is it less mass? Here we still have people that are saying less, so let's write the formula. A has got to be F over m, right? We're exerting more force, yeah? Or wait, nope. M is, I've got to get it right, F over A, yes? We're exerting more force and we're accelerating at a less rate. So that mass must be, it's got to be bigger. It doesn't have to be bigger. Okay. In fact, it's got to be more than 12 times as big, right? Okay. So let's consult the experts.
How many slugs are in?
Okay. Let's see if we can connect to the proxy server. Okay. Want to know? Let's figure it out, right? A slug. Ah, there we go. Google. Okay. So let's go 1 slug, because nobody believes me that a slug in kilograms. There we go. 14.59 or whatever. You know, if you believe Google, right? Always believe Google.
What about Wikipedia?
Yeah, so it's like 14.6 pounds. Could be confused with a stone, which is like 14 pounds. Okay. It's a measure of inertia. If you go into outer space, you still have inertia. You still have inertia in outer space. Now, this is a strange thing. And then when I was sitting where you were, I didn't have a grasp of inertia. Let me tell you this story. This is a funny story. Okay? If I were to right now walk out into the parking lot and I were to try to push an SUV, assuming that the SUV is parked there with its parking brake on, okay, I could not push it, and that would be largely not because of its inertia, but because it's touching the ground, and the friction between the tires and the ground would be too much, right? Okay? But if I were to float that SUV on some air bearings like this, yeah? Then in theory I should be able to push it because my force would be the only force acting on it, yes? Yes. Okay, so here's the story, right? I go to, my dad gets me these backstage tickets to tour the Guthrie Theater Company. This is a very fancy theater company in Minneapolis, Minnesota. When I'm backstage, they show us all these cool things. right? Like they've got night vision goggles to see where the actors are, and the set crew can move around in pitch darkness, right? And see where things are, right? But the coolest thing of all was that they would take these sets, and the set they showed me weighed 5 tons. Can we not do that? Guys? Can we put that away? Put the pen away? There we go. Okay. This set weighed 5 tons. And they float the set on little air pairings. They've got compressed air tanks inside the sets, and when they want to change the set, they just lift it up on like an 1/8 inch of air, and then they get a bunch of people to push on the set, and they spin them around, they move them off stage, they move a new set on, right? Okay, so they turn on one of these things. There's this 5 tons of inertia, or 5 tons of weight with tons of inertia, right? Okay, sitting there in front of me. And they said, go give it a push. And I walk up to the thing, and I go to push on it, and I'm like, and it felt just like that. It felt exactly like pushing on some immovable object. I'm like, and I give it the biggest heave-ho I can because there's no force acting against me, yes? It's going to go flying. No, it still has inertia, right? But I didn't get it. I'm like, you didn't turn the air. I thought they played a joke on me. Like they didn't turn the air feed on. That would actually be a little bit funny, right? Because they're silent. You can't hear them, right? No. I look, they go, oh no, look at it, it is moving. And I look at it, and the thing's sitting there like this. It's moving. It's moving like 3 centimeters a second or something. Right? And it just keeps moving in a straight line at a constant velocity. Right? The feeling I had, though, of pushing on it was just like, it's immovable. Right? So objects can be weightless, but they're never inertialess. You never are massless, unless you're something like hope or love. Yeah? Okay, wait, now see this I won like PowerPoint of the Year in 2003 for this animation. Wait. Okay. Weight is the force of gravity acting on an object. It is a force, so therefore it's measured in newtons. It's in newtons. It also is measured in pounds, and for the record, 1 pound, okay, is 4.45 newtons. This is a unit conversion that we failed to do when we launched something called the Mars Climate Orbiter. Okay, we launched a spaceship into space. Lockheed Martin, okay, calibrated the interface in pounds of force, pounds of thrust. Yes? Jet Propulsion Laboratory flew it as if it were calibrated in newtons. Because all scientists use newtons. Nobody uses pounds, except for Lockheed Martin, apparently, right? You know, Apple Pie, Chevrolet, pounds. You know, right? Okay, and so, sadly, but you know, JPL didn't read the user's manual. They didn't read the documentation, they didn't look at, they didn't check that. And so when you want to orbit Mars, here's what you do. You fly toward Mars, but don't head straight toward Mars, that's bad, right? You head to the side. Okay, now if you don't slow down, you just go off into space, right? So in order to get into orbit, you actually have to come in and slow down when you draw near, and then you get caught by, gravity acts like a little sling, slinging you around, right? Okay, so what they did was they came in here and they slowed down exactly 4.45 times too much. Yeah? They plotted an orbital trajectory that intersected the surface of the planet. That's a minor error, isn't it? Say millions, hundreds of millions of dollars worth of technology just turned into a giant meteor. I don't know. Someday we'll find that. It's like, dang. We should put a plaque up, right? Okay. So my cousin, okay, I'm like, my first cousin is like got a PhD in physics, and he designs spectrometers for space probes. He travels like all over the world telling people all the stuff that he does. He's so flippin' smart and everything like that, right? Okay, but whenever he tries to like rub it in my face and I'm just a high school physics teacher, I'll just go, hey, a pound equals 4.45 newtons. He works for Jet Propulsion Laboratories. It's like, hey. I actually did that once. He was like, it wasn't him. He wasn't the guy flying the spaceship, right? Okay, so here's the formula. The formula for weight